So good afternoon, students. We'll continue with topic number 2 of Unit 4, which is the same as the continuation of our previous class where we discuss about records at a construction site. So in continuation with our previous class, we already discussed five headings. This is the sixth one, which is the works passing record. So this record, the work passing record, is used to maintain all the activities that are to be carried out at a construction site. And this work passing records consists of an index page with details of all the items of works to be done under the contract and other pages with details of progress of each works. So this helps in tracking the progress report of each activity of construction and also helps in pre-planning for other remaining activities which starts after completion of the current activity. This also helps in acquiring approvals before time for activities that needs to be started. Number 7, test result record. This is an important record which is to be maintained at a construction site as a proof for construction quality. This record consists of tests of various materials such as cement, sand, aggregates, water, steel reinforcement used at construction site, test records of concrete cubes, concrete cylinders, slump test, etc. These records are arranged as an index page with details of each materials, page numbers of records, etc. So individual pages consist of each material with their test dates and results and so on. So all the test results that are carried out All the test results that are carried out in the site or in a laboratory are recorded in the record book. So some of the tests carried out at the construction site for civil works are mentioned below. The first one, cube test for concrete works for each location or structural members, sieve analysis of coarse aggregates, impact or abrasion test, sieve analysis of coarse sand for concrete works, masonry sands for masonry works, plastering and pointing works, etc. Test for impurities of aggregates and sands, bulking of sand test for concrete and masonry works, slump test and compacting factor test for concrete works, crushing strength test, tolerance test, water absorption test, efflorescence test of brick, stones or masonry work, moisture content of timber, and manufacturer test reports provided by the vendors for admixtures, reinforcing steels, etc. Next, cement register. So this record is maintained with details of receipts, daily consumptions, and remaining balance of cement at site. This record also consists of manufacturing dates of cement, date of receipt, and test reports of cement at the site or manufacturer's test reports. Number 9, register for approval of samples. This record provides details of all the samples for construction materials that has been approved or rejected by the client. Approvals from the client is necessary for the construction materials to be used before the commencement of the project. So all the samples approved by the clients needs to be kept separately along with their test reports with approvals of the clients and contractors till the completion of the work. Number 10, records of changes, deviation orders, and amendments. Many a times during the construction projects, there are deviations or changes or amendments to the contract documents and work activities from time to time during the construction project as required by the clients. These changes can be in drawing, specifications, or additional works. A record of all such deviation orders and amendments to contract agreement together with their financial effect should be maintained along with approval or signatures from the clients. If these changes involve in any extension of time of the contract, this should be also recorded. Number 11, measurement books. So the measurement book is a record of all the construction activities carried out and approved by the client. These records are important for a contractor to maintain and have during billing claims. Any extra work done is also recorded in this book with notes. Number 12, labor attendance record and daily wages sheet. So generally for labor contractor payments, daily or every shift attendance record is kept. Apart from the above technical staff attendance, engineer supervisors and peon attendance register is also kept. Number 13, periodic bills record. Bills on work till date from the previous bill and work checked by engineer in charge, that is the site engineer, puts up for the payment. So this is your assignment, weekly assignment. The question is explain all the resource constraints that we face in a project. And second one is explain the resource deployment. The last date of submission is given here. You can give your attendance in the chat box now. Thank you.
Is what is given in B. Now, this is precisely the kind of deployment of labor that we would like to actually see rather than the constant deployment as we have seen in the previous slide. What this slide shows is an alternative way of having employed the labor for completing the 500 or 300 man days of work. It really shows the deployment at different points in time, and the rest of it I'm sure you can figure out. Now, coming to our main discussion today, which is resource planning and scheduling. There are two aspects to our discussion. One is resource leveling, and the other is resource allocation. Leveling deals with distribution of resources within the fixed project duration, and allocation deals with availability of resources under a constraint. So coming to the first part, which is resource leveling, that is the process of allocating resources among various activities such that the peak requirement of resources is reduced with a constraint on time. And the underlying assumptions in resource leveling are only one type of resource is considered throughout the project, and activities already underway should be completed first. What I would like you to recall is that activities are of two types, let's say critical activities and non-critical activities. Critical activities are those which must follow one after another without any gap. Without any gap means there's no float. And at the completion of these critical activities, the project is completed. So basically, the last activity to be completed has to be a critical activity. That is by definition. Now, along with the critical activities, there is a set of non-critical activities with whatever dependencies they may have. Critical activities also have their dependence on non-critical activities, but there is some float, there is some leeway, independence in deciding when a non-critical activity is done. So the whole idea of resource leveling is to make sure that the resources that are used in non-critical activities are not spread out over the project sporadically. It should not happen that over a period of time, I need a resource here, then I need it here, then I need it here. If possible, I would like to bring these resources such that they are used here and here so that this particular resource can be brought to site only for this duration and be let go. Provided, of course, that this is for non-critical activities. In the case of critical activities, there's something which we may not be able to help much. So with this background in mind, let's move forward and try to understand the steps involved in the resource leveling process. Identification of critical activities, arrangement of activities on the time axis based on their early start dates, determining the total number of resources required on each day by adding the resource requirements of individual activities planned for that day and the resource profile determined as a chart called the resource aggregation or resource loading chart. As we do a simple example, these things will become clear. Repeat steps 2 and 3 with the activities being plotted using the latest start dates. comparing the two resource charts, that is that determined in step 3 and 4, and finding out an acceptable resource profile between the two extremes, eliminating the peaks and valleys in the resource distribution. This is done by arranging the non-critical activities within their float, which obviously means that the duration of the project is not compromised. Let's go through a simple example to understand this concept. Let me once again reiterate that what these steps essentially have told us is that a non-critical activity can start and finish as is shown here. If this is my earliest starting date for that particular activity, this is the duration of that activity, this becomes my earliest finishing time for this activity. However, without compromising the duration of the project, this activity can also be scheduled in this time frame where the duration of the project remains the same, and this is my last starting date or the latest starting date. This becomes my latest finishing date. This we get from the backward pass, and this is what we get from the forward pass. And remember that the activity can be scheduled anywhere between these two extremes, that is within EST and LST. If the activity starts anywhere in this region, it will get completed anywhere in this region, and this will not compromise the length of the project. So that is precisely the kind of thought process that goes on in leveling of resources. So let's understand this a little bit better through this example, which gives us the 7 activities as shown, their dependencies, and I've already drawn the network for you. So this here is the durations of all these activities. A requires 13, B requires 5, C requires 5, D requires 12, E requires 2, and F requires 5, let's say, days to complete, G requires 10. And this number here in the bracket is the resources. So in this case, as a simple example, we are saying that this number here represents the number of workers which is required to complete this activity. We must remember that as far as this example is concerned, we are also going to assume that A requires 2 workers, means it requires a team of 2 workers. It cannot be done or it cannot be started unless there are 2 people available. Further, it cannot be accelerated by putting more people on the activity. So with this understanding and assumptions, let's try to find out what can we do with the resource allocation algorithm which we have just learned. So the earliest and latest occurrences of the events are shown in the node, and they have been obtained by the forward pass and the backward pass. I'm sure you know how to do it. A can start at 0, and therefore this node here, which is node 2, the earliest it can be reached is 13. This node 5 can be reached earliest, depending upon the maximum of these 3 nodes which are converging on this, and so on. So we find out that activities A, D, and G are critical, and the project duration is 35 days. So this is the first step. We find that A, D, and G are critical activities. They are highlighted by a firm arrow, and we find that the project can be completed in 35 days. Now let's try to do the next step, which is scheduling these activities on the time axis. This representation schedules these activities in the earliest start times. So A obviously starts here, finishes at 13. D, which follows this, is completed here. G is completed here, and this is 35 days. As far as B is concerned, you will recall from the diagram that it depends on A and therefore can be started as soon as A is completed. And the same thing is valid for activity C. So these activities start here on, let's say, 13 and are completed at whatever times depending on their durations, and we reach these points as is shown here. Now, on this, if we now superimpose, what is the kind of resources that we need on each day? We find that as far as this point is concerned, that is, as far as the first 13 days are concerned, only activity A can be done. No other activity can be done, which means that A, which needs a team of 2 persons, is the only activity going on as far as this project is concerned, and our deployment is only 2 workers. Now, coming to day 14, we have the possibility of activity B, and C being carried out. D requires 2, B requires 3, and C requires 4 workers. And therefore, the deployment required as far as day 14 is concerned is 9. This continues till such time as activity C is finished. Once C finishes, we have activity F which may start, and so on. What we need to do is to find out on a given day what are the activities that are going on and find out what is the demand for the labor on that particular day. So we find that beyond this point, only activity G is going on, and that requires 4 people, and that's what we have. So towards the end of the project, we have only 4 people working on activity G right up to the end of the project. This is a scenario for starting all the activities on their earliest starting times. Now, if we represent this labor deployment on the time axis, this is what we get. So we have 2 people here, increases to 9 here, goes to 8, 5, drops to 2, and then goes back to 4. What we have to see is whether this is the most desirable form of labor deployment or not. In order to be able to do that, let's try something else. Let's try to schedule the activities so that they start at their latest starting times. What we are trying to do is to ensure that G, which is the last activity, and depends on the completion of activity E and completion of activity F, is not delayed, because this is my critical path. In order for this to happen, we must make sure that activity B starts here, activity E starts here, C starts here, and F starts here. And that is precisely what is their latest starting times. So now with this algorithm, or with this thought process, let's try to then find out what is our labor deployment. This is what the numbers you will get. From here to here, it will be all 2s, then it goes to 6, 9, 8, and goes back to 4. Representing this on the time axis in a manner that we did the last time as well, we find that we have possibly a slightly better situation. We have 2, 6, 9, 8, and 4. Now the point is, can we do something better than that? Now let's do yet another iteration with the same example. So let's try to do another iteration and try to see if we can remove the peaks further and reschedule our non-critical activities. But what we must remember is that we must remain within the floats of these activities. Now, with this thought in mind, that we'll use the floats and try to reschedule the activities, let's do this iteration. In this one, what we are saying is that activities C and F, which is here, are starting at their earliest starting times, which is somewhere here, and B and E are starting at their latest starting times. And with this, if we do the resource aggregation, we find the numbers to be given as they are at the bottom. This is the graphical representation of the resource profile that we get when we have chosen to start one set at the earliest starting times and one set at their latest starting times. Now, before we compare these 3 resource curves, I must point out that here we find that the peak demand of resources has reduced from 9 to 8. Now, this picture here shows the comparison that we had. This was when the activities started on their earliest starting times. This is what we have when we have the activities starting at their latest starting times. And this is what we have when we did the combination of EST and the LST for the different activities. Personally, to me, this seems to be the best alternative that we have so far. We can try another. You can work out more examples or more combinations with BE and CF separated. What we have done is B and E have been taken to both start at the same time. B and E have followed each other. C and F have followed each other as soon as the previous one was completed. So as soon as B was completed, E was started. As soon as C was completed, F was started. We can separate these 2 activities because we can say that B we will start at the earliest time and E we will start at the latest time. So if we do these kind of combinations, you'll probably be able to generate more resource aggregation curves and then make a judgment on which is the most desirable form. It may also be governed by availability and so on. And that is the next topic of discussion today. That is allocation of resources under a constraint regime. Now, coming to the discussion on resource allocation under a constraint, the resource allocation is performed when the availability of resources is constrained. Due to limited availability of resources, some activities may have to be necessarily delayed. The basic objective is to find out which of the activities can be delayed and finally arrive at the shortest possible time to complete the project satisfying resource constraints. This may or may not result in the delay of the project. Inasmuch as we will try to ensure that the project is not delayed by finding out the critical activities, trying to make sure that the critical activities are not starved of resources, at times it may become impossible to avoid, and that is something which we have to deal with. And if we plan enough, we are able to flag these issues in advance. Now, as far as the steps which are involved in resource allocation, these are the following. Identify the critical activities in the network, allocate resources day-wise. If at any time the resource requirement exceeds availability, then allocation of resources to activities should follow the following rules. Rule 1, critical activities get the first preference. Rule 2, ongoing activities should not be stopped in the middle. Rule 3, allocate resources to activities that have the least earliest starting time. And rule 4, if two activities have the same EST, then allocate the resources to the activity that has a lesser flow. Please note that activities may be rescheduled due to resource allocation, which may result in activities that become critical. Once we are playing around or shifting the non-critical activities, their starting points, their scheduling, that may lead to a change in the critical path. And that is something which has to be constantly kept in mind. It should be ensured that the above is accounted for in making a decision based on the above rules. This change in the critical activities should always be there as a governing principle when we are trying to do the reallocation of resources. Now let's look at an illustrative example for this. Let's consider the same example in which the project takes 35 days to complete normally. Now we will assume that the maximum availability of resources on a given day is 8. So recall that the maximum resources that we had in a lot of our simulations that we ran was 9. Determine if there is any delay in the project completion. Again, we carry out this first exercise and find out that A, D, and G are critical activities with the project duration of 35 days through the forward and then the backward pass. Now this here shows a graphical representation of activities starting at EST with their float. The float is what we have added to the previous diagram, and this is our resource aggregation diagram. And we note that till day 13, activity A that has a resource requirement of only 2 is carried out, and that is not a problem because the maximum available resources is 8. Now on day 14, however, the resources need to be allocated to activities D, B, and C if they have to start on their respective ESTs. Now the total resource requirement on day 14 therefore turns out to be 9, which is exceeding the available limit of 8. So we have to find out which of these activities needs to be supported. How should the resources be allocated? And for that, we go to the rules that we have just gone through. If we look at this tabular representation of the rules, we have activities D, B, and C competing for the resources. The resource requirement for these activities is 2, 3, and 4 respectively. And we write down whether these activities are critical or not, whether they are ongoing or not, what is the earliest starting time of these activities, what is the float. Now, based on this, we have to assign the priorities. So in this particular case, activity D is a clear winner in the first round because it's a critical activity. So it gets priority number 1, but it has only a requirement of 2 resources. Now, since more resources are available, basically the competing activities are B and C. Now, which of these gets a priority would be determined by the float in this case. And in this case, C has a lower float and therefore gets a priority 2.